Dear students, now we are going to see the subject transmission lines and RF system. Under that, the topic is line constant for zero dissipation. On completion of this line constant for zero dissipation, the students will be able to derive the condition of a line become dissipationless, as well as they are able to find the line parameters by using the given data. In general, the line constant for a transmission lines or the characteristic impedance Z0 that is equal to square root of Z by Y. Z represents the series of impedance which is equal to R plus J omega L. Y is shunt arm admittance that is equal to G plus J omega C. So substitute this Z and Y in the characteristic impedance. So we are getting Z0 is equal to square root of R plus J omega L by G plus J omega C. Gamma is a propagation constant that is equal to alpha plus J beta, which is equal to square root of Z into Y. So gamma is equal to square root of R plus J omega L into G plus J omega C. So according to the standard assumption for line at high frequency, J omega L is much greater than R and J omega C is much greater than G. That means the resistance and conductance of a dissipationless line is zero. So substitute this condition in the characteristic impedance and propagation constant gamma. So characteristic impedance Z0 is equal to square root of J omega L by J omega C. So Z0 is equal to root of L by C. Similarly, the propagation constant gamma is equal to J omega L into J omega C. So J square is given by minus omega square LC. So this can be written as J omega into root of LC. So here in a dissipationless line, it only has the imaginary part, that is the real part attenuation is 0. So equate the real and imaginary parts of the above equation. So attenuation alpha is equal to 0 and beta is equal to omega root LC. So the velocity of propagation is written in terms of the ratio of omega by beta. Here substitute the beta value is omega into root LC. So the velocity of propagation becomes 1 by square root of LC. Lambda is the wavelength. It is represented by 2 pi by beta. Beta is equal to omega root LC. So the wavelength lambda is equal to 2 pi by omega root LC. So these are the line constants for a dissipationless or a high frequency line. So one of the possible quiz question is the propagation constant of a transmission line with the impedance and admittance are given. So here we are going to determine the propagation constant by using the expression gamma is equal to square root of Z into Y. Z and Y is given. So substitute this value, find the product and you take the square root and you are getting the answer. Thank you.